Okay guys, so in this video we're going to talk about instantaneous dipole-induced dipole forces. Instantaneous dipole-induced dipole forces are non-polar forces. They are dependent on the number of electrons present in a particular molecule. The greater the number of electrons, the greater the MR. Basically, MR also carries a mark over here, so make sure to mention the MR, even though you know that it's a trivial word. You might think it's a trivial word, but make sure to mention it always in your answers. So what are the factors that affect instantaneous dipole-induced dipole forces? So the factors that affect instantaneous dipole and induced dipole forces include the MR. The greater the MR, the greater the ID forces. The second point that you always have to mention whenever explaining the factors affecting the instantaneous dipole-induced forces is the number of polarizable electrons. Okay, the greater the number of electrons, basically we just use the term polarizable electrons for that because it carries a mark, and then the stronger the instantaneous dipole-induced dipole forces. All right, so make sure to know the three particular facts: greater MR, greater number of electrons, stronger instantaneous dipole-induced dipole forces. And we always mention this for nonpolar compounds, especially hydrocarbons. Hydrocarbons in general are the trend in hydrocarbons as the number of MR. For example, if you talk about a butane homologous series, its members methane, ethane, propane, butane, and so on, its members are increasing in their MR, increasing in the number of electrons, increasing their strength of increasing in their melting and boiling point. So in that case, you have to mention the fact that the number of electrons are increasing, MR is increasing, therefore the instantaneous dipole-induced dipole forces are becoming stronger, and therefore greater energy is required to break them. All right, so that's about instantaneous dipole-induced dipole forces. Now, what are instantaneous dipole-induced dipole forces? You don't need to know in detail actually, because there's never a question asked in detail. But what is asked on the exam is the following fact: to identify the type of bonding that is present in a particular molecule. So the type of bonding that is present in all hydrocarbons or all non-polar molecules. For example, even if it is an oxygen molecule, O2, it's a diatomic molecule. And diatomic molecule, even though it's oxygen is highly electronegative. But since it's a diatomic molecule, both the molecules will cancel each other out, right? Their electronegativities will cancel out, hence it's going to be a non-polar molecule. And you still have to talk about the instantaneous dipole-induced dipole interactions. Now, make sure to know the fact that whether it's hydrogen bonding, permanent dipole, or ID forces, all three of them, you guys know that are intermolecular forces, and therefore intermolecular forces mainly determine the physical properties of a particular element or a compound, or an element. All right, they only affect the physical properties. They do not have anything to do with the chemical properties. All right, physical properties mainly includes melting and boiling points, solubility, viscosity, and even the flammability, even the volatility. All right, all of these properties are physical properties, and they're dependent on the intermolecular forces for simple molecular substances. All right, for simple molecular compounds, simple molecular elements, for example halogens in general, starting from fluorine all the way to iodine, are nonpolar, and hence if they are nonpolar, I'm talking about the molecules, so they would have ID forces. And if they have ID forces, if you talk about the group trend of halogens, as you go down from fluorine to iodine, the MR increases, the number of polarizable electrons increase, and the strength of van der Waals forces, strength of ID forces increase. Hence, the state changes from gas on top to solid at the bottom. You know that fluorine and chlorine are gases. Then bromine is actually a liquid, right? It's an orange-brown liquid. Then after bromine comes iodine, which is a dull black solid. Then after that acetylene. Acetylene is radioactive, therefore we don't talk about it much. But if you are asked to guess or suggest the type of bonding that is present in iodine, or the physical state that iodine has, acetylene has, so the answer would be the answer would be dull black. Okay, for iodine it's shiny black, but for acetylene it should be dull black. The reason for that is because first of all the color is becoming darker and darker as you go down the group, and secondly because the MR is increasing, the number of electrons are increasing, and hence the strength of ID forces is also becoming stronger. So more energy would be required to overcome them. Therefore, the physical states also convert from gas to liquid to solid. All right, you should be able to explain these trends in terms of ID forces. Then another question. Now for the rest of the questions, all right, I'll just mention it in this video. The next question is comparison across the three types of intermolecular forces. Okay, for example, they'll give you three compounds. They'll give you water compared to H2S and they'll ask you the question. This is a literal MCQ, exam MCQ, that is not only asked over there, but also asked on the MDCAT exam, also on the NUMS exam, also on AKU exam, and even on here in A levels and in all of the boards. All right, this is a very commonly asked MCQ of comparing water against H2S. And the question is, why is water a liquid whereas H2S a gas? So the answer for that is very simple, because water has hydrogen bonding whereas H2S has van der Waal forces. Now what are van der Waal forces? Van der Waal forces is a term that is used to collectively represent both permanent dipole, and instantaneous dipole-induced dipole forces. Alright, it is used to represent both of them collectively, and hence in this case H2S, because it is also polar, because sulfur will have a electronegativity higher than hydrogen, but the fact that it's not that high makes the statement correct that it's not hydrogen bonding, it is van der Waal forces. And van der Waal forces, you know that hydrogen bonding are the strongest of all intermolecular forces. Therefore, hydrogen bonding requires more energy to be broken. Hence, water is a liquid, whereas H2S is a gas, because the H2S, intermolecular forces of H2S. The intermolecular forces are the ones that are responsible for the physical state. So the forces responsible for physical state in H2S are weaker compared to H2S, compared to water. Hence, it's easier for them to be broken down, and therefore H2S is a gas. All right, that's the first question. Second question is, if we compare water against methane, for instance. So that's going to be very simple. Reason? Because methane is non-polar, water is polar. Secondly, because water has hydrogen bonding, and hydrogen bonding are the strongest type of intermolecular forces, whereas methane, it has IDID forces, which are the weakest of all. Alright, therefore most energies would be required to overcome the hydrogen bonding in water, and the least energy would be required to overcome the IDID forces in methane. Therefore, water has a higher melting and boiling point. Alright, so the comparison across different molecules. Always remember, you will only be asked to compare the simple molecular structures. Okay, for example, why iodine is a solid whereas HCl a gas. Okay, so that's because HCl has permanent dipole. Whenever you are mentioning or explaining in terms of physical properties, you always have to first identify the type of intermolecular force that is present in a particular compound. All right. So HCl, for example, has permanent dipole interaction, whereas iodine has IDID forces. But since the MR of iodine is way greater than HCl, and it has much more number of polarizable electrons compared to HCl, therefore it would have the much stronger IDID forces compared to the permanent dipole interactions in HCl. Therefore, iodine is a solid, whereas HCl is a volatile gas. All right. So that's another example. But this is very rare, comparing IDID with PD. What they usually do is they compare van der Waal forces against hydrogen bonding. All right. This is just one type. And this is an MCQ that is very commonly asked. So for instance, if next time a question comes to compare iodine with bromine, for instance, why bromine is a liquid, iodine is a solid, you would be able to compare. Reason? The three standard facts that you need to remember always and almost always have to include in your answer is the following: that iodine has a higher MR, greater number of polarizable electrons, stronger IDID forces, therefore more energy would be required to break down the iodines in IDID forces compared to bromine's IDID forces. Hence, iodine is a solid. So the 3 points are higher MR, greater number of polarizable electrons, stronger IDID forces. These 3 points have to be mentioned always. Okay, I can't stress this enough. And then, what is IDID forces? The definition, the explanation. Well, if you are curious, you can just find that out. But in my opinion, if you just want to study for the exam, make this rapid. What you need to do is just understand the questions that are tested on the exam. And the questions that are tested on the exam for IDID forces are the ones that I just covered in the video. All right? The factors that affect IDID forces and the compounds that have IDID forces. Non-polar compounds in general. Hydrocarbons in general. Methane, ethane, propane, butane. Or if we talk about alkenes also have them. All right? And similarly, they might give you a list of increasing alkenes, for instance, and they might ask you, why are alkenes Why is the melting point of alkene becoming higher? Or why is the flammability decreasing? Or why is the volatility decreasing? Why is the viscosity increasing? All of these can be the questions that can be tested. So whenever such a question about a physical property is asked, and you see that there's a trend in physical properties of nonpolar compounds going down the group, then you always mention the fact that in terms of the physical properties, all right, in terms of the MR increasing, number of polarizable electrons increasing, and hence ID forces becoming stronger. If ID forces become stronger, then that would mean flammability is going to decrease, solubility is also going to decrease. Well, they are insoluble anyway, so it's okay. Apart from that, viscosity will increase. Apart from that, melting and boiling point will increase. All right, so you need to mention all of these physical properties. Viscosity increases. Okay, so I guess that wraps up intermolecular forces. All right, always remember intermolecular forces are mainly, they determine the physical properties of simple molecular substances only, okay, not of giant molecular substances. Giant covalent structures have different interactions that we will talk about. All right, they have covalent bonding on which their melting point depends. Giant covalent structure, I'm talking about silicon dioxide, graphite, diamond. All right, they have covalent bonding, which are much stronger. They are the strongest, in fact, compared to all of the type of chemical bondings that we've studied so far. Diamond is the hardest of all, right? But we will study that in the next video. Till so far, we've completed intermolecular forces. So I hope this will save a lot of your time reviewing the stuff. Thank you.